Hello, this is Nicole Green. Welcome to this educational module on the comparison between gamma irradiation and heat inactivation on viral load. If you have any questions during the presentation, please type them in the chat and we will discuss them at the end. We hope this is beneficial to you and your company. Thank you so much for taking the time to attend. Animal serum is commonly used in a wide variety of products, from cell culture and vaccine manufacture to cell and gene therapy. Its exceptional ability to provide the nutrients needed in these applications make it essential in furthering science and the subsequent benefits to humans and animals. ISIA and serum companies take this responsibility seriously and are continuously trying to reduce the risks that are commonly associated with the use of animal serum. One of these risks is the introduction of advantageous agents. Most regulatory bodies allow the use of animal-derived products because of their success and the lack of an alternative. Companies providing these materials take great care in providing safe products for use by processing and testing each batch thoroughly. There are many methods available for control of microorganisms in a variety of products, but due to the nature of animal serum, many of these are not used. Each batch of fetal bovine serum is filtered through 3.1 micron filters to remove microorganisms, but this is not effective for viruses. UV, or ultraviolet germicidal disinfection, is used widely in water systems and for surface disinfection in hospitals, but is not commercially available for use with animal byproducts. We'll talk more about the heat inactivation later. Chemical treatment was performed many years ago using beta-propiolactone, but the dangerous nature of this chemical rendered this process not commercially available. Electron beam technology uses ionizing energy from an electron beam, but this is not able to penetrate at the level needed for treatment of animal serum. X-ray technology also uses ionizing energy, but from a rototron electron beam. It is able to penetrate at greater densities, but it also is not commercially available. Gamma irradiation uses photons from a radioisotope and can be used at higher densities. Rosie will cover this in detail later on in the presentation. Many tests are performed on each finished lot of serum, and a certificate of analysis is produced that lists all the testing. ISIA has a guidance document to explain this testing. It can be found in the standardization section on the ISIA website. Each lot of serum must be tested for all types of advantageous agents, bacteria, mycoplasma, and viruses. Bacteria and mycoplasma are removed by filtration, but because of their small size, viruses are not. So each batch of serum is tested for many viruses. Most regulatory agencies have their own set of rules for what animal serum must be tested for when used in certain applications. To further reduce risk, many users gamma irradiate serum. And once again, Rosie will speak more on this later. Sometimes animal serum is heat inactivated for reduction of viral load. A few points of clarification. Heat inactivation, as we will discuss in this presentation, is the process of heating serum to 56 degrees for 30 minutes. This is different from the definition of heat treatment found in EU Regulation 1069 for animal byproducts that requires a temperature of 65 degrees Celsius for at least 3 hours, or reaching a temperature of 80 degrees Celsius. Those two methods will damage the serum, so it cannot be used in cell culture and other applications. Heat inactivation was originally designed to inactivate complement, but over the years, companies have used it for reduction of viral load. It is a long-standing procedure in many cell culture labs and is included in many biomanufacturing protocols. The most common method requires bottles to be completely thawed and mixed well by gentle inversion. The bottles are then placed in a water bath deep enough to ensure the level of the serum is fully covered by the water in the bath. When the bottles reach 56 degrees Celsius, leave them in the water bath for 30 minutes. Bottles must be agitated in this process to prevent protein aggregation on the bottom of the bottle. This heat inactivation process can also be performed in bulk using sophisticated whole tank heat exchangers. There are some concerns with this process. Studies have shown a decrease in performance of some cell lines using serum that has been heat inactivated. There can also be variability in the process if it is not performed correctly. These include adequate mixing of bottles, ensuring each bottle is at temperature for the required amount of time, and the depth of the water in the bath relative to the height of the serum. Also, depending on the desired outcome, different times and temperatures may be required. Now I'm going to turn it over to Rosie, who will talk about gamma irradiation and then compare these methods for viral load reduction on some specific viruses. So here's Rosie.
So, what about gamma irradiation? It's a more complex but better controlled methodology and has been in use for quite some time. The method of action of gamma irradiation can fall in one or two categories. Indirect action involves irradiation at ambient temperature with no scavengers in aqueous solutions and with oxygen present. Direct action, on the other hand, is at a very low temperature. There are scavengers and there's low oxygen. So the preferable method of choice for gamma irradiation of serum is the direct mechanism, as it minimizes the unintended damage to critical components and leaves the serum appropriate for use in cell culture. Irradiation is performed in sealed product containers at extremely low temperatures. Minus 60 degrees C is preferable. And this results in the inactivation of microorganisms in a manner that is first order with respect to radiation dose. So the more you irradiate, theoretically, the more direct viral inactivation happens. And this methodology is effective on all but small unenveloped viruses. So here's a picture of an irradiation facility. So the serum is loaded into specially designed and configured irradiation containers, and most people have their own way of doing this. And so it is company specific. The dry ice is added to the container in order to reach very cold temperatures. Those containers then are moved through a maze, all the way through this maze and into the source chamber. The maze is to protect the outside from the irradiation from the cobalt that's in the source chamber. Once it gets into the source chamber, it's moved around and it stops at a couple of defined locations on both sides of the source. Then it comes back outside down this way and is unloaded at this point. Subsequent to that, a certificate of irradiation is generated, and the most important thing on the certificate of irradiation is the radiation dose. So the dose is a function of the design of the irradiator, the intensity of the radiation source, the cobalt, the density of the product as it's actually loaded into the container, and the time spent in each position around the source. This is a little graphic that shows you the difference between irradiating serum and irradiating regular products such as plastic bottles. If I go through the low density product, the plastic bottle routine, first of all, there's routine dose mapping performed. It's not that complicated, and you can actually do it on the plastic bottles. The product comes in on a standard truck. It doesn't need anything special. It's stored in standard conditions. It's loaded in a specified configuration, and runs through the irradiator. Then it goes back in a truck and goes away. Serum, on the other hand, has to be treated rather differently. The PQ dose mapping uses a simulated material. It does not use serum, just because of the nature of the product. The receipt of the material, which comes in a refrigerated truck with frozen serum, then has to go into a freezer to be stored until it's going to be irradiated. Once it's loaded into the containers for irradiation, the dry ice will be added and then it will be irradiated. Sometimes during the process, it has to be re-iced, which causes another complication. It then goes and then gets shipped out in a refrigerated truck. So it's more complicated, largely because of the dry ice and the fact that it has to stay really cold. And that means it cannot be run unattended. If you're irradiating bottles, you can load things up and go home for the weekend. If you're irradiating serum, somebody has to be there. And that can lead to difficulty in scheduling. It's not always amenable for the irradiator to stop everything in the middle of a week to do a run of serum. So that can lead to some longer lead times than you would want. So what do we know about serum and serum irradiation? We know that a reduction of 4 logs of viral load is considered effective, and that's based on the viral load generally found in the serum. As you all know, a lot of serum is composed of material from many animals, and some of those animals may have a high viral load, but when you put that many samples together, you're going to end up with a low viral load overall. It's not like they're all going to be screamingly hot. There might be a couple. So 4 logs is considered effective just based on that fact. Small unenveloped viruses are the least sensitive. We know that. Higher doses will destroy the biological activity of the serum. I call it making soup. And so alternative risk mitigation strategies are required. That could be downstream processing. That can be various treatments prior to the product being released. But what needs to happen in each case is there needs to be a risk-benefit done for the specific virus that you're concerned about, managing to make it through the manufacturing system. I've already said each configuration must be dose mapped. So you can't say to somebody, well, you do irradiation for company X, so just use the same protocol. You have to understand that the gamma irradiation is in fact getting all through the load in the configuration that you are using. And the last thing is that the radiation dose is always a range. The tighter the requirement, the more difficult it is to get that exact number. Most regulations require 25 to 30 kilograms, and that is something that will give you the required viral load reduction, but also keep the serum happy. This is a little graphic that actually I stole from GSK and give them credit for, of the viruses that are affected at different levels of gamma irradiation. So here we have 25 kilograms, and it's very clear that BVDV is being killed at this point. And so all of this is good. These are all enveloped viruses, and so you're getting a good amount of viral load reduction in all of these situations. If you go up to 35 kilograms, you'll get blue tongue a little bit better, but you've still got all these small unenveloped viruses like parvo that are not being hit by the irradiation. And so, you know, you can crank it up a lot higher, but all you're doing is killing the serum. So now let's switch gears a little bit and talk about the effectiveness of gamma irradiation on a few specific viruses, just to give you a picture. And the examples we're using are viruses of concern from the USDA risk assessment that was completed a few years ago, and that concluded that gamma irradiation was the best currently available risk minimization technology. So we have blue tongue, foot and mouth, BVDV, bovine viral diarrhea virus, and we've added in Cache Valley, because Cache Valley is not on the list, but it is a relatively new virus of concern, and there's a lot of conversation about it. Now, this table here gives you the overview of the relative sensitivity to gamma irradiation and heat treatment. It is fairly well understood at this point that viruses of a certain family tend to have the same sensitivity to gamma. And so that's why we care about what's the virus family, what kind of genome does it have? Is it enveloped, yes or no? How big is it? Because that can have an impact also. What's the regular kind of irradiation dose used? And these are just examples. There's a lot of information available, but I've kind of extrapolated here, so I'm making some generalizations. So, for example, for Cache Valley virus, you're going to get a 5 log to the 5 reduction in viral load, which is a good number. We already said 4 is really good. We're looking here at highly sensitive viruses, and they're both enveloped, and that makes sense to us all. The blue tongue is not quite as susceptible to gamma irradiation, but does in fact get pretty well dealt with. Foot and mouth disease, the last one on this list here, is an interesting one because very little work is done with foot and mouth disease in terms of looking at things like this. You may remember that several years ago, there was a leakage of foot and mouth virus from a highly contained lab in the UK, which resulted in a lot of animals having to be culled. So most people don't want to have foot and mouth virus anywhere around. The data that's available here was actually done by some brave people in Canada. But I have given you a comparison based on the family history of swine viral diarrhea virus, which is a family member of foot and mouth disease virus, and it gets a log 10 reduction of 6. So what we have here is a good indication, 5.7 and 6, that this is something that would make some sense. So then what happens if you use heat? You can see here that BVDV looks pretty good with heat. You can see that both CVV and FMD would show about a 50% reduction in log reduction. And you can also see that blue tongue is really not tremendously affected at all. And so that leads us to a couple of conclusions. It is definitely surprising, I think, that heat can in fact provide quite a bit of viral reduction if properly controlled, and if all of the concerns that Nicole expressed earlier are actually taken care of. However, given the variability of it and its overall lower effectivity, we don't recommend it as a practice for routine viral load reduction, unless it's been shown to be necessary for a specific cell culture application. So we've talked already about the fact that you may need to use heat to inactivate complement, and that's something that absolutely works and is often important. So you will be able to find detailed references on all of this stuff at serumindustry.org/gamma irradiation. There are 6 papers detailing the procedures required in gamma irradiation, and there is a summary white paper that does this comparison in a bit more detail. Now, what we've done today has been a high-level look at these 2 post-manufacturing treatment methods. If you would be interested in a more in-depth review of gamma irradiation, please let us know. We find that a lot of people still struggle to understand gamma. There are a lot of misconceptions still out there, and we're very happy to provide any more education that we can on this particular subject. So let us know if you're interested. And thank you for your time and attention. And we look forward to having your questions. Please put them into chat so that we can answer them appropriately. Thank you. Hello, everybody. It's Rosie. I am very happy in this instance to introduce you to your new CEO of ISIA, Ms. Robin Kisrow. She and I have been joined at the hip for a whole of 10 days now, and she's really getting to grips with what a delightful bunch of people you are and how complicated serum really is. So we do have some questions, and we can start answering them. First of all, I actually texted you. Sorry for tripping over my tongue halfway through that. I'm quite sure what happened. But people always think that I just do nothing but talk, but I was speechless for a moment, so I apologize. Ton has pointed out that heat inactivation is not necessarily a method for viral reduction. In fact, it is to some extent, but it is not the recommended method for the reasons that we have stated. It's virus dependent, it's concentration of virus dependent, and it's a lot more difficult to control, as we said several times. So the recommendation from the ISIA, which reinforces what the US government concluded after their risk assessment, is that gamma irradiation is currently the best method for viral load reduction. Here we have a question about detecting BV/DV after gamma irradiation. That's very unusual because BV/DV is really quite susceptible to gamma, very susceptible to gamma, in fact. I guess a question would be whether your irradiation load, your irradiation concentration was high enough. Depends very much on, as we said, the dose amount can have a significant effect. I'd be happy to answer more questions on that or discuss with you, some of the details. So if we could figure out some more to help you with. The next question, what type of virus requires greater than 30 kilograms? Really, when you're talking about that kind of dose, you're talking about small unenveloped viruses, and they're, past a certain point, they're not susceptible either. So it's a difficult situation. Usually what has to happen is you have to look at the virus you're worried about and the application that the product's going to be used in, and you can design in checks and balances to your downstream processes that will make sure that nothing gets through to the far end, if I can put it that way. Hopefully that helps to answer that question. If you go back and look at the slide that I showed, that will give you a little graphic of that, and that will be available as obviously this is going to be put up on our YouTube channel. So hopefully that will help you as far as that's concerned. I'm sitting here laughing at the person who said, "Hi, Robin." Not sure that's a question, Sheila, but she seems to be okay. Elizabeth Mullinax has asked, does the EU requirement of greater than 30 to 45 negatively impact the serum? The kind of Bible, if you like, for Europe for serum is the EMEA documentation. I'm not sure where this 30 to 45 is coming from, Elizabeth. But the EMEA is in the 25 to 30 range. If you're going to run into difficulty at 30 to 45, there will be viruses that will be negatively infected. Affected, not infected. Goodness me. What a twit. Lauren Nolan wants to know, what are scavengers? Scavengers are molecules that are present in serum that help to absorb some of the negative impacts of the irradiation. And there's a huge protein burden in serum, and a lot of it is BSA. So that's the kind of thing that can really pick up some of the materials. No scavengers would be a very dilute solution. Maybe a buffer, something like that, would not have that capability. So hopefully that helps. And Lisa Dixon says, thank you for this presentation, and thank you for everything you do for us at the U.S. Department of Agriculture, Lisa. Any other questions? Hopefully this has been helpful. We really would be interested in knowing if you all would like to see a more detailed discussion on gamma. We think that it's a very important topic, to the extent that we had a task force that wrote 6 papers on the subject. And then also we've done this, documented this comparison with heat and with gamma. So hopefully there's something there. So please let us know. You can vote on chat if you like to, just whether that would be something that would be of more interest. I've always thought it entertaining that when I started getting involved in gamma irradiation, people would say things like, well, every big company has their own irradiation facility. Not. It's a very, very heavily controlled industry. And so it's something that is not just lying around for everybody. So, here's Mesrad says, a more detailed training will be very helpful. So we will look for anybody else who's interested, and hopefully that's something we can do in the very near future.
Oh, and Rosie, I'm getting adept at this platform clearly while you're speaking and answering all the questions. But I actually see that Tobias has asked a couple of questions in the private chat to us. So Tobias, I hope you don't mind me just calling you out here, but I found those by accident. So he has asked, is there a relation comparing effectiveness on single-stranded versus double-stranded virus genomes?
Is there a what?
Is there a relation? Is there a relation? I can't spit out words right now either.
It's all right.
Is there a relation comparing effectiveness on single-stranded versus double-stranded viral genomes?
I know there's data that would compare it, but I've never heard that it was something that made any significant difference. But that's a good question, and we could investigate and get Tobias an answer. What is this?
We can look at that. I say we can look at that in the next presentation as well, maybe correlations between those two.
That's a good idea, Nicole. Yeah,
exactly. The next one is, what about effectiveness on DNA versus RNA viruses? So
same thing.
Exactly. Related.
Yes. That's something that we, as Nicole very cunningly suggested, we could make that part of the next thing.
Exactly. And I would say if you are interested, as Rosie said, in a more detailed presentation, it looks like we've already had a couple people put that into the chat, but please do you can just put yes in the chat, or just indicate, so we just have a little bit of a pulse check on the interest from the group. Thank you, guys.
We have another observation from Lauren has come back and said that the European Pharmacopoeia says that bovine serum should be irradiated with a dose of at least 30 kilograms. 30 kilograms is fine. 35 to 45 or 30 to 45 can get into the edge of destroying or diminishing the ability of the serum to grow cells. So 30 is fine. Lots of people now coming in. Hey, Toby, no worries. Glad we found your questions. Various people are saying that they would like to have a gamma irradiation detail presentation, so we will start working on that. Gavin Hoggard is asking why X-ray is not considered a suitable alternative as high power X-ray is becoming more available. I know there's been some experiments done, but the commercial availability of equipment that would do that, Gavin, is not yet with us. I think it may be something that we get to in the end. People have tried UV, but and X-ray to some extent, but it's a situation where we just don't have enough. We don't have big enough pieces of equipment to handle it. So hopefully that helps with that. Okay. We got the message. There will be another session on gamma. ASTM might be a useful resource on gamma irradiation. Who is ASTM?
That's a test and measurement.
Ah, yes. We can explore what they have as information.
Yeah.
Okay.
Excellent. Yep. I know we have to kind of pause. There is a delay, so we're just making sure no more questions come through. There's a delay on our end. So just making sure no more questions come through before we close this out. Thank you, everybody, for your feedback. All right. Thanks again, everyone. We'll be in touch about future educational modules.